Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. In this video, let me discuss about the direct mapping and then we will discuss the drawbacks of the direct mapping. Now, to make you understand the direct mapping, let me take a small example. The cache memory is having 16 words. The size of the cache memory is 16 words and the main memory size is 32 words. The same example I have taken in the last video. The main memory size is 32 words and block size is 4 words. Now you know that the main memory is divided into blocks logically and cache memory is divided into lines. So if each block can store 4 words, out of 32 words, you can store them in 8 blocks. Block number 0 to block number 7, block number 1, block number 2, 3, so on up to 7. How I got number of blocks is equal to main memory size by block size. What is the main memory size? 32 words are there. What is the block size? 4 words, so I will get 8 blocks. Similarly, when it comes to the cache memory, the number of lines is equal to cache memory size by line size. As you already know that the size of a line is equal to the size of a block. Okay, so cache memory size is 16 words and the line size is 4, so you will get 4 lines. So line number 0, line number 1, line number 2 and line number 3. Okay, so we have arranged the 32 words in 8 blocks of the cache memory and 16 words in the cache memory. We can arrange them in the 4 lines. Now, if you see that what is a mapping, as you have 8 blocks, these 8 blocks you can have to keep only in the 4 lines, any of these 4 lines. Suppose let's take that block number 0 is there, where you have to keep. Whether you can keep it in the line number 0, can you keep it in the line number 1, line number 2, similar line number 3, where you have to keep. That will talk in terms of a mapping. So nth block of a main memory, in which line you can keep it in the cache memory, we will call it as a mapping technique. Already we have discussed that we have 3 types of mapping techniques are there. One is direct mapping, another one is associative mapping, and the third one is set associative mapping. In this video, we will discuss about the direct mapping. In direct mapping, the nth block of the cache memory, the nth block of main memory can be kept in nth line of cache memory. How can I identify nth block of main memory? In which line I have to keep it is, now remember one thing, line number is equal to block number modulus number of lines in cache memory. Number of lines in cache memory. It is very simple one. In which line you have to keep it is that block number modulus number of lines in the cache memory. Let me discuss with an example. I need to keep the block number 3. So block number 3 in the main memory should be kept in, how many lines are there? Block number modulus number of lines in the cache memory. Number of lines is 4. So 3 modulus 4 is 3. So you need to keep the block number 3 of the main memory in the line number 3 in the cache memory. So in this line you have to keep the block number 3 of the main memory. Now as we have 8 blocks, let me discuss with another example. I need to keep the block number 8. In which line of the cache memory I can keep? 8 modulus 4 is equal to 0. So in the line number 0, you will keep the block number 8. Similarly, if you have block number 2, 2 modulus 4 is equal to 2. So you need to keep the block number 2 in the line number 2. Let me discuss, as we have 8 blocks are there, what are the blocks can become in the line number 0? Block 0 can come, am I right? Because 0 modulus 4 is 0. Block number 4 can come. Block number 8 can come in the line number 0. Now, what are the blocks can come in the line number 1? 1 can come because 1 modulus 4 is 1 only. Then 5 can come. Okay, 1 and 5 are the blocks can come in the line number 1. In line number 2, you will have 2 and 6. Second block and sixth block of the main memory can be kept in the line number 2. Similarly, 3 and 7 can be kept in the line number 7. So, you got all the blocks 0, 1, 2, 3, 4, 5, 6, 7, 8. So, all the 8 blocks of the main memory, you can keep it in some of the locations of the cache memory. Am I right? Now the problem, so I hope you have understood what is the direct mapping. So in nth block of main memory where I have to keep it in the cache memory, you have understood. Now what is the drawback? Now let's discuss with an example. What is the drawback? If you see that I have to access the block number 0, okay, block number 4, block number 7, block number 3. Let's take that. Okay. Now, as we discussed earlier, we have 8 blocks in the cache memory. Sorry, in the main memory. 4 lines are there in the cache memory. Am I right or wrong? The same example I am continuing. 4 lines are there, which is line number 0, line number 1, line number 2, line number 3. Now I have to access the block number 0, where the block number 0 will be kept in the line number 0, because 0 modulus 4 is 0. So you will keep the block number 0 in the line number 1. Now you need to access the block number 4. Whether the block number 4 is there in the cache memory, it is not there. So it is a miss. So you will go and search it in the main memory. In the main memory, the block number 4, you have to keep it in where? Cache memory, 4 modulus 4. You have to replace this one because 4 also need to keep it here. At a time, only one block you can keep it in a line. But if you see that remaining 3 blocks are empty, 3 lines are empty, however, you need to replace the block number 4 you have to keep by removing the block number 0. Are you able to understand? Similarly, block number 7 is there. Block number 7 where you will keep 7 modulus 4. You will get 3. In line number 3, you will keep the block number 7. Then again block number 3 came. So 3 modulus 4 is equal to 3. Even the 2 lines are empty. However, you need to remove the block number 7 and keep the block number 6. So that is the drawback of the direct mapping, because you have a fixed location for each block in a particular line. So if it is still other blocks are empty, we cannot use it and we have to keep it here. So that is the drawback of the direct mapping. So I hope you have understood what is a direct mapping and what is the drawbacks of the direct mapping. Now let me discuss how the direct mapping is organized, or how the address space is organized in the direct mapping. Okay, so let me take it. The main memory size is 32 words are there. Am I right or wrong? And the cache memory size is 16 words. And block size is 4 words we have taken. And main memory have 8 number of blocks in main memory is equal to 8. That's what we have taken the example till now. The number of lines is equal to 4. Am I right or wrong? Now if you have a 32 word main memory, are you able to understand? If you have a 32 word main memory, the CPU will generate the physical address 5 bits. Because CPU will fetch will generate the physical address depend on the size of the main memory. The size of the main memory is 32 words. So using 5 bits, you can locate the 32 word address spaces. So 5 bits physical address it will generate. Now, how the direct mapping will divide this 5 bits physical address is, already in the last video we have discussed that it is basically divided into block number and block offset. Am I right or wrong? The block offset will be depend on the size of the block. In the previous video we have discussed that the block size is 4 words, so you need 2 bits as for the block offset. Totally 5 bits are there. 2 bits are allocated for the block offset because you have 4 blocks. And now, how many blocks are there in a main memory? 8 blocks are there. So 8 blocks can be recognized using 3 bits block number. So this is the way we have discussed a particular word can be searched from the main memory. Now we will discuss the same 5-bit physical address is divided into how many parts when it comes to the direct mapping. Okay. The total 5 bits, you will have the block offset. You will have 3 parts. One is the block offset, and you will have the line number, and you have the tag bits. So in direct mapping, the physical address is divided into 3 parts. One is block offset, line number, and tag number. Okay. So now we will discuss how many bits are allocated for the tag, how many bits are allocated for the line number, how many bits are allocated for the block offset, or even you can call it as a line offset also, because even it can be a block offset or it can be a line offset also. Now let me discuss how many bits are required. The total bits are 5 bits. Will you accept it or not? Because main memory size is 32 words, so the total address space is 5 bits. Now as you have a block size as 4 words or a line size, block size is equal to line size is equal to 4 words. So 4 words can be recognized using 2 bits. Okay. So line offset or a block offset consists of 2 bits according to this example. Now what is the line number? How many lines are there in the cache memory? 4 lines are there. So 4 lines can be recognized using 2 bits. So 2 bits are allocated for the line number for this example. So totally out of 5 bits, 4 bits are allocated for the line offset and line number. 1 bit is allocated for the tag. So the remaining bits will be allocated for the tag. Okay. Now we will discuss with an example how a particular word is there in the cache memory, whether how it is can be represented, we will discuss. Okay. Now if you see that cache memory is divided into 4 lines. Line number 0, line number 1, line number 2, line number 3. Even I have discussed that each cache memory line will have a tag. This tag is useful for us to identify particular word is available in the cache memory or not. We have said that each line is associated with a tag. In this example, the tag size is 1. 1 bit is allocated for a tag. Okay. Now if 1 bit is allocated for a tag, now each tag can be either 1 or 0. Am I right or wrong? 1 bit is allocated for a tag. In each line, the particular tag can be either have a value 1 or a 0. Let's take that this is having value number 0, this is having 1, this is having 0, this is having 1. Let's take that 0, 1, 0, 1 is there for the line number 0, line number 1, line number 2, line number 3 respectively. Now if you see that I want to search the word number 7, 7, 5 bits I need to represent, so 0, 0, 111. Okay, this is the word number 7. Okay, now word number 7, if you take it, this is the tag bit. Okay, and these are the 2 bits are allocated for the line number, and the line offset is 1, 1. Are you able to understand? Now if you see this, now remember one thing. In our example, 32 words are there in the main memory. So you have block number 0 to block number 7. Block number 0 will consist of word number 0, 1, 2, 3. Block number 1 will consist of 4, 5, 6, 7. Okay. Are you able to understand? Block number 1. So block number 1 where can be kept in a line? the block number 1 can be kept in line number 1. Why? How we can get it? Block number modulus the number of lines in the cache memory. Block number 1, the number of lines in the cache memory is 4, so I can keep it in the line number 1. So block number 1 I can keep it in the cache memory. Okay, are you able to understand? So now how can we do it? Please listen carefully. How we can identify whether it is available or not? Even block number 1, block number 5 also can be there, but which block is available we will search it. How we can search it is that, now first check it. You have given the word number 7 is there. Now word number 7, first you will go and search the line number. What is the line number is there? 0, 1. What is the meaning of 0, 1? If you convert into decimal number, 0, 1 can be represented as 1 into 2 power 0 plus 0 into 2 power 1, which is equal to 1. So you need to go to the line number 1. Okay, are you able to understand? So line number is given as 0, 1 for the word number 7. So it is line number 1. So the particular word can be available in this one. Now you need to search. Tag bit is 0. So if tag bit is 0, but if you see that tag bit is 1 here. So if the tag bit is 1, then you can say that word number 7 is not available in the cache memory, because this word is saying the tag bit is 0. But in your cache memory, the tag is assigned for this line is 1. So you will not search for the entire word whether it is there or not. You will search first the tag. How you can search? First you will go to the particular line by using the line number. In the particular line, what is the tag value is here and what is the tag value. If it is both are matching, you will use a comparator to check it whether it is matching or not. If it is matching, then you can say that it is a hit. Okay, otherwise it is a miss. Why I can say that it is a hit? Because if you take a particular block, all the words will be there. Am I right? Suppose let's take that if a block number 1 is there, then word number 4, word number 5, word number 6, word number 7, all the words will be there. Am I right? Because a block consists of 4 words in this example. Are you able to understand? Then you can ask me, what are the words are possible if you have a tag bit as 1? Am I right or wrong? Sir, you are saying that my word number 7 is not available. Then what is the words are available if the tag bit is assigned 1? As the tag bit is assigned 1, okay, the line number is what? Is 0, 1. So take the line number. Now out of 5 bits, 3 bits are fixed 1, 0, 1. Then remaining 2 bits can be 0, 0, 0, 1, 1, 0, 1, 1. Am I right or wrong? 3 bits out of total 5 bits address, 3 bits, 1 bit is tag and 2 bits are for the line number, and the remaining 2 bits you can keep 0, 0, 0, 1, 1, 0, 1, 1. Then in that case, what are the values you can get? If it is 1, 0, 1, 0, 0, okay, then the value is, this is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. Then you can have 2 power 4 is 16, 2 power 2 is 4. So word number 20 can be there. Okay, then this is word number 21, this is word number 22, word number 23. So if your tag bit is 1 and the line number 1 is 0, 1, then word number 20, word number 21, word number 23 are there, currently are there in this line number. Okay, 23 are there. Okay, now if you still have a doubt, let me discuss with another example. Let's take this line. This line is having the tag bit as 1. Okay, now what is this line number? 3. So 3 can be recognized as 1, 1. Obviously here it will be there 1, 1. Am I right or wrong? Then the remaining 2 bits is 0, 0, 0, 1, 1, 0 and 1, 1. Am I right? So these values are same. Now what is the value here? It is 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4. 2 power 4 is 16, 2 power 3 is 8, 2 power 2 is 4. So this is 28. Am I right? 16 plus 4, 20. So word number 28 will be there. And this will be word number 29. If you want to verify, you can convert this binary number to decimal number, you will get 29. And this is 30, this is 31. So if tag number 1 is there in a line number 3, these are the words are possible. Word number 29, word number 30, word number 31. Which block it will have word number 28, 29, 30 and 31? Out of 32 words, then line block number what? Block number 7 will be there. Am I right? Because block number 7 only will consist of word number 28, word number 29, word number 30, word number 31. Yes, block number 7 can be fitted in the line number 3 according to the direct mapping. So this is the way we will identify whether a particular word is there in the cache memory or not. We will not search the entire cache memory. First we will search the line number, then we will go to the particular line number. If it is matching with the tag bit, then it is a hit. If it is not matching, then we will say that it is a cache miss. So I hope you have understood how the tag will be useful to identify whether it is a hit or a miss. If you still have any doubts related to this concept, feel free to ask me in the comment section. I will clear your doubts in less than 24 hours. If you still does not understand, don't worry. Next video I will take few examples or numerical examples to make you better understanding. Thank you so much for watching my video. Have a nice day.